All right, so welcome back, guys. This is video 9 for composition of functions. Now, this is a little bit different than what we've seen before. Let's go ahead and just jump right into that one and see what we're talking about. So composition of functions, it's not multiplication. What it is the term composition of function just refers to the combining of functions in the manner where the output from one function becomes the input for the next function. So let's do
Mr. Nelson, how come it says fog?
Yeah, let's get there. That symbol right there is not an O. Let me circle it really quick. That circle right there is not an O. It's an open circle. Even though it looks like an O, it's not one. What that means is we're going to be composing or using composition of functions here. And what that means is we're going to basically taking whatever we have here and inputting it into G first. And then whatever we get out of that function, we are going to output that and then input it into our f function. So again, it comes back to our definition. The output from one function becomes the input of the next one. So let's take a look at this.
I'm still confused.
Yeah. Calm down, Mr. Craig. Calm down.
Well, Mr. Nelson, it says it's not multiplication, but when you write it with parentheses on the right, that still looks like multiplication.
Right, yeah. I mean, so we definitely want to look at these parentheses down here. We do have a lot of parentheses, and this does look like multiplication, but remember when we're talking about functions, we're talking about inputs and outputs. So right here is another way to write it, f of g of x. We're going to find whatever g of x is first, get the output from that, and then we're going to input that output into our f function. So it's not multiplication like we're multiplying right here. That's not what that is saying, because this is function notation, not multiplication. Does that make sense, Ms. Johnson?
I think you should just show me how to do it.
Yeah, I'm lost.
So another way to write it, here's our first example. We're just going to talk about how we can rewrite this g of f, which looks like goff this way, but it's just g of f of 3. So basically, you're going to take your g, but we have a different input to find first. Remember, we need to plug the 3 into f first, like f of 3. So again, if you were to follow the order of operations, you have to look inside the parentheses first. So we would need to solve for f of 3 first. And then whatever we got out of that as an output would be inputted into G. So that output would become the new input for G. So let's take a look at an example.
So it's not G of 3 and F of 3?
No, because again, it takes the input of whatever f of 3 is and inputs it into G.
Oh, okay.
So the order here does matter, and we're going to show that in just a second. So let's get into our first example. Here we have two functions. We have the function f of x and g of x. F of x is 4x minus 2, and g of x is x to the power of 3, or x cubed. And the question is to do composition. You'll notice, how do I know this is composition?
A circle.
Yeah, it's a circle right here instead, right? That circle right there means composition, not multiplication. If that were a filled-in circle, then we can go back to our previous videos and do the multiplication. So let's take a look at what this means. Let's rewrite it from our definition from before. The f, open circle, g of 3 is the same thing as saying f of g of 3 like so. And if we were to follow the order of operations, we'd have to do everything inside the parentheses first, which would mean that we need to solve for g of 3 first. So we're going to input the 3 into the g function right here and get our output. So let's do that really quick. Let's put 3 into the function g really quick. What is g of 3?
3 times 3 times 3.
Yeah, because right here it says it's x to the power of 3. X to the power of 3, we have to remove the x first and then replace it with the input. And remember that 3 to the power of 3 is not 3 times 3. It's not 9. It's 3 times 3 times 3, like Mr. Craig just said. So g of 3 is going to be 27. Okay? So now that we know what g of 3 is, that the input, again, let's talk about that. The input was 3 and the output was 27. So once we input a 3 into g, we got out a what?
27.
A 27. So what are we going to put into f?
I always put the 27 on the top of the arc because that way I remember.
So that way, when we get the 3 and we get out the 27. Now we have to plug in the 27 into F. So there's two ways to look at that. You can look at it this way right here, or you can look at it this way that I've got here on the right-hand side. Let me change this real quick. So now we have to find F of, well, what was G of 3?
27.
27. So we're just going to replace G of 3 with 27. Now we need to go find F of 27. What is the function F, though?
4x minus 2.
So we're going to do 4 times x minus 2. But what was x in this case?
23? What, 27?
27. It's right there, Mr. Craig.
Oh, okay.
All right, and then we can either use our calculator at this point, go over to Google, type that in exactly how you see it, and get your answer. Or you can do it by hand. 4 times 27?
108 minus 2.
And 108 minus 2 is?
106.
And so if you were to bring this all the way down and keep on writing it, you have F of G of 3 equals 106. So let's recap that again really quick. So the first thing we had to do is find G of 3. We did that over here, and we got 27. So that became the output of G of 3. And so we take that output, and now we substitute it into F to find F of 27. And then we found F of 27 by doing 4 times 27 minus 2, just by substituting into our first function here, and then doing our math and our order of operations to get 106. Anything y'all would add to that?
No, I like to keep track of my numbers. So when I go on the first part there where you have F parentheses G parentheses 3, maybe in the top of that arrow, I would put 27 and then put an arrow from the 27 to the F. That's kind of how I do it.
So because you got G of 3, you plugged in 3, and you got out a 27. Now you need to plug 27 into F, like so.
Yeah.
Perfect.
Kind of follow. It's like going backwards. Yeah. Let's try another one. I think I'm kind of getting it now.
Yeah. So on the same with the same functions, we're actually going to change this up a little bit different. You'll notice here on this one we did F of G, right? So we had F of G right here. On this one, we're doing it a little bit differently.
Oh, is it 106?
It wouldn't be 106. I'm going to show you that G of F and F of G are actually two different approaches to the math. So, and they're actually
obviously one is fog and one is goth.
So it looks different. So I would hope to expect a different result. So let's go see if we get a different result, though, just to prove it here. Again, the other way to write this is to do G first, because G comes first here, and then F, and then inside parentheses again, we're trying to find F of 3. So input the 3 into F first, and then whatever we get out of that, we're going to plug into G. So let's go over here to the side, and let's find F of 3. Again, we're going to be using the function F here. So 4, remove the X, minus 2. And 3 is going to replace our X. That's what's going in the parentheses. We can do our 4 times 3, which is 12. 12 minus 2 is, yes, the silence.
10!
There we go.
10!
F of 3 is 10. And so right here, we're getting F of 3. F of 3 is 10, so that becomes our new input here. And that means we're going to be plugging 10 into G. Same thing as over here. We found F of 3. We plugged 3 into F. And now we got out a 10, so now we need to plug in and that is a horrible arrow. There we go. So we need to plug a 10 into G here. So let's do that real quick. So G of, what are we plugging into G this time?
10.
10. So let's go find G of 10 here.
It's the blue one.
It's the blue one, you're right. So let's go find, we'll go blue here. G of X is X to the power of 3, but remember we are going to remove the X and do to the power of 3. Again, we're using the function G. So what are we plugging into G this time?
10.
10. See, we're plugging in 10 into G, right? So we have to replace this X right here with 10.
10.
All right, so what we have left here is, if I'm going to bring all this down, we have g of f of 3, and 10 to the power of 3 is 10 times 10 times 10
1,000.
gives you 1,000. You guys can use a calculator for that if you need to.
That's way different than the last one.
It is. So on our last problem, even though they're the same functions, one's f of g and the other one's g of f, the last problem we got 106. And we just, the only thing we changed is we put g of f instead of f of g, and we got a whole different number. So that just kind of goes to prove that f of g and g of f are not necessarily going to be the same. Here's another illustration for you. I'm going to hand this one off to Mr. Craig to kind of explain this.
Ooh, I got this one. Okay, so it says f of x equals pizza, and g of x equals pineapple. So f of g of x, well, if I put an x back to the g, little arrow there, that means I'm putting in x into g, which is pizza. All right, so I got pizza, and then I'm taking, oh no, G, look at me. G is a pineapple. I'm taking pineapple, and I'm going to put pineapple into my pizza. And so I end up with pizza with pineapple on it. It's beautiful because I put the pineapple into the pizza.
That's right.
But on the other one, I have G of f of x. So I'm putting x into f, which is a pizza. So I get pizza. And then I'm taking pizza and I'm putting it into pineapple. That's just weird. So the order matters. One gives me pizza with pineapple on it, and the other one gives me pineapple with pizza on it. Patent pending. Those still my ideas. So the order obviously matters because you do not want to go order yourself a pineapple with a piece of pizza on it. You want a pizza with a piece of pineapple on it. That's cool. I like it.
So let's just go ahead and let's prove that again. I've got two different functions here. I got f of x and g of x. F of x is 4x and g of x is 2x to the power of 3. And I'm going to find in A, I'm going to do f of g of 3, and then on B, I'm going to do g of f of 3. Again, nothing much different except for f and g are in a different order. And again, like we just said, the order does matter. So let's go ahead and rewrite these really quick. This is going to be f, and then inside of f, we are going to find g of 3. And so we need to substitute 3 into g first. So let's go ahead and do that part. G of 3. Just take this g function here and do 2 times. Remove the x to the power of 3. And we're going to substitute in the 3 for x this time. How do we go about this one here?
Well, order of operations says parentheses, can't do the parentheses, then exponents, 3 to the third power is 27, and then we would do multiplication or division, whatever we see first, and we only see multiplication, so we go 2 times 27. That's going to be a whopping 54.
All right, so we get 54 for g of 3. So we plug 3 into g. Change this color up. We plug 3 into G, and we got out a 54.
And we can put that in the Google thing like you did last time, Mr. Nelson?
Use that Google.
We didn't want to try to figure it out as long as we put the parentheses?
Yep, that's right.
Okay.
So now we need to find, we're going to plug 54 into F. Again, G of 3 is 54, so we're just going to replace that with 54. And now we need to go find f of 54. Oh, that's all together. I'm writing too big. I'm going to run out of room. So let's go find f of 54. It's going to be 4 times x. In this case, x is 54, if you're wondering where I got that from. F of x is 4x, and so I'm just replacing the x with 54. And 4 times 54 is?
216.
216. I'm going to write that in the same line there just because I'm running out of room. So f of g of 3 is 216. So let's go look at the other end of that. Let's flip the f and g around so we have g of f. Let's go see what we get there. This is going to be the same thing as saying g, and then inside g we plug in f of 3. In other words, plug 3 into f first. Let's go find f of 3. Function f is 4x. Replace the x first with some parentheses and then substitute in 3. 4 times 3 is 12. So f of 3 is 12. And now that we have that, we are going to take 12 and substitute that into g. So g of 12. Again, just replacing f of 3 with that. What is g? G of x is 2 times x to the power of 3. Remove the x and plug in a 12 in this case. And follow those order of operations.
12 times 12 is 144. Times 12 is 1,728. But I would just stick it in Google.
Yeah, if you type all of this into Google, you'll be good. Just remember to use that caret sign for it. And what you end up here is with 3,456.
56.
3456.
Wow, that's completely different.
Yeah, and you'll
Order
notice
matters.
the answers are completely different. So 216 versus 3,456. So order
keep it in order.
Matter. Keep it in order. So if that kind of makes sense to you guys can move on to your practice. We are going to cover one more problem.
But you don't have to if you're getting it. This is just for those of you who want to make sure you understand it.
That's right. So let's take a look at this. Not all functions are g and f or f and g. This one's we have h and f here.
Hoff.
And it's asking me to find h of f of 3. So
We use 3 every time. Do we always use 3?
No, we don't always have to use 3. That input could be any number.
That's Mr. Craig's fault. He was being lazy. Nice catch. Let's change it. Let's make it h of f of 2.
We can do that. So let me erase this. Let's change that up.
Or 5. Let's make it 5. 5's fun. I like 5s.
Let's just do away with that altogether. How about that? Let's do it differently.
Okay. H of f of 5.
5.
Nice call, Miss Johnson. Thanks for throwing me under the bus.
Let's do h of f of 5. So another way to write that is h and then in parentheses f of 5. So in other words, if you kind of just stick to order of operations, you know that you have to work inside parentheses first. You have to plug that 5 into f, which is just f of 5. So let's go find that really quick over here on the side. See here, f of 5 uses the function f, which is right here. I'm just going to replace those x's with parentheses. Sorry, I got a dot there. 3 times x plus 2. And we're plugging in a 5 here in our parentheses. Follow your order of operations. This 3 times 5 comes first there. 15 plus 2, which is
17. And again, you can put that in your Google if you didn't know. I mean, I hope you do know. But if you don't be scared. Use the technology.
Use the technology if you need to. So now we know what f of 5 is. We plugged 5 into f, and we got out a 17. So now we need to plug the 17 into h. What's h of 17? So we're going to use the function h, -7 times x minus 5. And we are plugging in a 17 here. -7 times 17?
-119.
All of it or just the...
No, just the first part. -7 times 17 is -119.
Okay, and then minus 5?
-124.
There we go. So we get the h of f of 5 is -124.
Cool. Hopefully that makes sense to everybody. There's also a video. Actually, this is the video. Never mind. You can also get on Zoom if you're completely lost. Try a couple of these problems. Get on Zoom and ask away if you don't get it. If you don't get it, it's Miss Johnson's fault. If you do get it, it's all because of me. If you're somewhere in the middle, ask Mr. Nelson.